everyone, now we will start 4.6. First thing is fundamental theorem of algebra. So fundamental theorem of algebra says if a polynomial has a degree n, it has total n solutions including repeated, including complex. Okay? A polynomial of degree n where n is greater than 0, then it has total n solution including repeated. Sometimes a root is repeated, so I have to count it into 2. If it's repeated 2 times, I will count it has a 2 roots. Complexes. If I say complex, real is already in. Okay. Let's start with the first question. It says, how many solutions does this equation x cubed plus 3x squared plus 16x plus 48 equals to 0 have? The degree of polynomial is 3. So it has 3 solutions because degree is 3. In this x power 4, it has a 4 solution. We are not counting here how many real, how many imaginary, and how many are zeros. Okay, so just the solutions, it's counted everything. Real solution, complex solution, both are counted. Next question says find all zeros of this polynomial. Polynomial is provided. And what is this? The last number is negative root. So yesterday we learned about rational root theorem. So I will use that first. Minus 8 over 1. The factors of minus 8 is plus minus 1, plus minus 2, plus minus 4, plus minus 8. So these are possible rational roots. If you divide each root with plus minus 1, it has no effect. It's still same. These are possible rational roots. So let's try for a 1. I'm using syntactic division. I choose for 1. 1, 0, 1, minus 2, minus 12, minus 8. Because x power 4 was missing, so I have to keep 0. 1, 1, 1, 2, 2, 0, 0, minus 12. And it is minus. It's not giving you the term. So 1 is not a solution. Now choose for negative 1. Negative 1, negative 1 here. Negative 1 into negative 1. Positive 1, 2, minus 2. Minus 4, positive 4, minus 8, plus 8, so 0. So you are getting x equals to minus 1 is the one of the solution. X equals to minus 1. So after doing so, whatever left, again choose the same thing. 1, minus 2. I am applying the syntactic division again on this. Let's check it satisfies again or not. Okay, so I choose for negative 1 again for this case. 1, negative 1, negative. Positive 2, 4, negative 4, negative 8, positive 8, so 0. It means negative 1 is repeated 2 times. So after removing the factor 2 times, you left with this polynomial. Okay, let's try with the other things. 1, minus 2, 4 and minus 3. If I try positive 1 here, it will not work. If I try negative 1, 4, 5, 6, it is possible. Let's try 1. 1, negative 1, 1 down, negative 1, it's negative 3, positive 3, 7, no, not working. Use positive 1. So positive 1 is not a solution because at the starting, if positive 1 is the solution, it must satisfy. When I check here 1, it must satisfy. If it's not satisfied with the starting, so you don't need to check that factor again. 1 is done, negative 1 is done. Now try for 2. 2 as this, 1 down. 2 ones are 2, 0. It's a 0, 4. 4 2 is a 8. So yeah, 2 work. X equals to 2 is one of the remaining. This is left. I can write in a simple quadratic equation. Constant x square. So what is that? The equation is x square plus 0 plus 4 equals to 0. X square equals to 4. X equal minus 4. X square equals to minus 4. So x is plus minus 2 times I. So you can count. There are total 5 zeros. 1, 2, 3, 4 and 5. Total 5 zeros and we calculate all. Alright. This is how we solve for all zeros. Even the repeated is there. I counted 2 times. Because it's repeated 2 times, I count 2 solutions. Next, complex conjugate theorem. Complex conjugate theorem is if the polynomial is a rational. If, or you can directly say in rational polynomial, if a plus iota b or a plus ib is a root, then its conjugate a minus ib is also a solution. Even it is not mentioned in that, you have to consider the conjugate as a one of the solution. Make sure your polynomial is a rational polynomial. A rational polynomial means when the coefficient of each term is a rational number. Okay, rational. Let's try this. Write a polynomial function f at least degree that has a rational coefficient. A leading coefficient is 1 and the zeros are 2, 3 plus I. 2 is as it is 0. 3 plus I is a 1 of the 0. You just write here, if you have a plus ib is the root, then a minus ib is also the root. It is possible if a minus ib is the root, then a plus ib is also the root. So I will write 3 minus I. This is also the root. Now how many roots are there? Total 3 roots. 3 roots, least degree can be 3. Why I'm using the word least degree? Because it is possible I can make this as a repeated value. It can be repeated. So least degree is 3. Degree is 3. We have to find a polynomial. So from x equals to 2, so factor is x minus 2. From x 3 plus I, it's x minus 3 minus I. X minus 3 plus I. Now you can consider this as a single term. X minus 3 as a single term. If you consider x minus 3 as a single term, it looks like a minus b, a plus b. If you multiply, you get a square minus b square. First factor as it is. When you open the brackets, it will be x square minus 6x plus 9. I square is negative 1. 1 negative is already, so plus 1. Okay. Then you can calculate it further. X square minus 6x plus 10. Now multiply with this. X cube, 6x square, 10x. Minus 2x square plus 12x minus 20. X cube as it is. Minus 8x square plus 22x minus 20. Done. So this is the polynomial you got after expanding it, the factors. Okay. Next is Descartes rule. Descartes rule is used to find out how many possible positive real root, negative real root, and complex. First is check how many times sign of terms is different. That is number of positive real root. In the terms of fx. Okay, so this is positive real root. If now same thing, you have to check how many times the sign of f of negative x is changing. You have to check how many times sign changes here. How many times sign changes here. Okay. And if the degree of polynomial is odd, it has at least one real root. I think with the example it will be more clear. Okay. Original function is given this. Check it how many times it changes the sign. There was a plus sign and there is a negative. So one time sign change. This negative and then positive. Second time sign change. Positive to negative, negative to negative, no change, negative, negative, no change. So one time, two time, and three time. So three times sign change. So it has 3 times sign change. So I can say it may have 3 roots. 3 minus 2, always subtract 2, even number. 3 minus 2, 1. If you again subtract 2, you will get negative, so you don't have to go to negative. Up to 0 is done. Either it has a 3 positive real root or it has a 1 real root. Now I am calculating f of negative x. It's negative x power 6, negative x power 5, negative x power 4, negative x power 3, negative x power 2, negative x, and this averages. On open, it is x power 6, it's 2 times x power 5, it's 3 times x power 4, it's 10 times x power 3, and it is negative 6x square plus 8x minus 8. How many times it changed? No change up to this. Plus change to negative. There is a plus, plus, plus. So no change. Plus change to negative, negative to positive, positive to negative again. So total 3 times sign change. 3 times sign change. So it may have 3 negative real root, 3 minus 2 is 1. It may have either 3 or 1 negative real. Now check imaginary. Imaginary roots in a rational polynomial always occur in pairs. So how many pairs you can form? It may have 2 complex roots, 4 or 6. It may have 2, 4 or 6 imaginary solution or imaginary solution or roots. Okay, let's see next. As I'm subtracting 2 from the each number, 2, 4, 6, it may be 0 because we are subtracting 2 from it. 6 minus 2, 4, 4 minus 2, 2, and 2 minus 2, 0. It has these roots. Make sure the total will be 6 roots. How many real are there? How many imaginary are there? Total will be 6. Okay. So this was the concept. to counting number of sign change. Next question is, a tachometer measures the speed at which an engine shaft rotates. For a certain board, the speed x of the engine shaft has a speed s of the board are modeled by this. Speed is modeled like this. What is tachometer's reading when the board travels 15 miles per hour? So you have to check what is the value over time. We have to find x when sx is 15. So substitute as a 15, 0.00547 x cubed minus 0.225 x cubed plus 3.62 x minus 11 points. So shift 15 to the other side. 0.00547 x cubed minus 0.225 x cubed plus 3.62 x minus 11. You can subtract 15 from it. It will be negative 26. Yep. So this is the polynomial you got. You have to find roots in this. You will find number of roots. And this will be done with the graphing calculator. We have to use graphing calculator here. So here I use the Desmos graph here to calculate this. You can see their intersection is 19.86. So you can say it is approximate 19.9 revolutions per minute. So it is a value in hundreds of RPMs. So you can write the total and multiply by 100. 1990 RPMs. Then this is the answer. Okay. So what we calculate? We calculate the reading here. So reading comes out 1990 RPMs. This question done. Make sure you understand the question here. The starting is given 50 not for the x. This is given for s. You can check the units. Miles per hour. Your sx is also miles per hour. So your s value was provided here. It says when s is 15, what was x? Calculate that. Okay. So this was 4.6 Fundamental Theorem of Algebra. I hope you understand. And any doubt you can ask in the comment section. Thanks for watching.